Yes, sir.
Hyperconjugation, no?
Yes, sir.
Okay, fine. Please, you have your notebook, right? Pen notebook already, na?
Yes, sir. Ready.
Okay, fine. So we have learned many things till here in electronic displacement, right? We have learned many things in electronic displacement. We have learned about, first of all, we learned about inductive effect, right? Then we said that inductive effect is plus I, or there is minus I. Then we learned about the resonance, right? Then we learned about resonance. From resonance, we saw that there is plus M and there can be minus M. And then we learned about hyperconjugation, right? We learned about hyperconjugation. So all of these things now, they will help us in understanding the stability of intermediates. Stability of intermediates. Okay, so intermediates are, there are how many intermediates? We will have carbocation, we will have carbon ion, right? Or we can have carbon free radical. Yes or no?
Yes, sir.
Yeah. So now we know that we have carbon, which is a carbocation. That means it is what? It is electron poor, right? It is electron poor. Then all the plus group, they will be, that is plus I plus M, it will be stabilizing the carbocation. Carbon ion, it is what? It is electron rich. So all the minus group, right? All the minus group, they will be stabilizing the anion. And also we know that the free radical is also electron poor. It does not have 8 electrons. That means all the electron donating effects plus I plus M, they will be helping. But what about resonance and what about hyperconjugation? What about resonance and what about hyperconjugation? If I look at hyperconjugation is again, let's say it's like this, right? So it is stabilizing. See, you can see that there is delocalization of the. So what is happening? This carbon, it is sometimes getting neutral charge, right? It is not, it is removing its positive charge and it's getting neutral. And hence we can say that hyperconjugation is also what? It will stabilize the carbocations. It will stabilize the carbocation. And also, but we cannot say the same thing for carbon ion. Why? Because this carbon ion, it is what? Already electron. It is already electron rich. It cannot form more bonds because it already had 8 electrons. It already has 8 electrons. So how? We have, so there are 3 bonds. These are 2 hydrogens. So you can see 2 electrons here, 4, 5 and 6, 7 and 8. And that is why there is no hyperconjugation. If you have CH2 negative, you should have a CH2 positive, or there should be CH2 free radical, or there should be alkenes. Okay, there should be alkenes. So we'll talk about the stability of alkenes after we have talked about the stability of intermediates. So we can say about carbocation, number 1, carbocation. So carbocation, these are stabilized by, they're electronic poor. So stability, it is directly proportional to plus I, directly proportional to plus M, directly proportional to hyperconjugation. That means it's directly proportional to number of alpha hydrogens, right? If the alpha hydrogen is more, hyperconjugating structures are more. And it is what? It is inversely dependent. It is inversely proportional to minus I. It is inversely proportional to minus M. Yes or no?
Yes, sir.
So you can either write this down, or if you have this in mind and you can apply it without remembering, because these are what? These are, I can say these are very logical things. So you don't have to remember them, because if something is electron poor, then if you add electron withdrawing group, it will make it more electron poor. That means more unstable. Okay. This is about carbocation. Second is carbon ion. Okay. Now carbon ion is what? It is electron rich. And hence what will happen to the stability? It is directly proportional to the minus I. It is directly proportional to minus M. Okay, it is now. It is also directly proportional to the resonance. If you have, it doesn't, resonance means what? Identical resonance. If you have CH2, double bond CH, single bond, CH2 negative. If I compare this and if I compare this, then in this case, I can say that there is resonance. That is why there is delocalization of charge. That means what? This charge is what? It is spread around this carbon and this carbon, the whole molecule, and hence it is more stable. Okay, so the resonance, if it is present, then carbon ion is also what? More stable. If there is no resonance, okay, resonance, and if there is no resonance, that means the resonance one will be more stable. Then what else? It will be inversely proportional to plus I, will be inversely proportional to plus M. Okay. Similarly, here also, if you don't have any plus I or any group, and if you have resonance, then also it is directly proportional to resonance, because resonance is stable. It is stabilizing it is stabilizing charges. Okay, resonance will stabilize charge. It doesn't matter whether you have a positive charge or you have a negative charge. Okay, but if you have special kind of resonance, that is mesomeric effect, then you have to look whether the group is increasing the electron density or it is decreasing the electron density. Okay. Can I move?
Yes,
Yes
sir.
or no? Similarly, for free radical, what is going to happen? We'll have carbon free radical. Okay, carbon free radical. Now, in carbon free radical, you will be having electron poor. This is electron poor. And if this is electron poor, that means the stability, it is directly proportional to plus I, directly proportional to plus M, directly proportional to hyperconjugation, directly proportional to the number of alpha hydrogens, directly proportional to resonance. Okay, it is inversely proportional to minus I, it is inversely proportional to minus M. Okay.
Done, sir.
Okay. So wait a second, let me give you some questions. Okay, I have quite a range of questions. Okay. One more thing, that for example, if I say, if I want to compare the stability of, compare the stability. So I have CS3 positive, and let us say I have carbon and if I have okay, so in this case you can see that there is no effect here, and here you have hyperconjugation, here you have resonance. Yes or no? Tell me.
Yes.
So in this case you will always say that resonance is what? Greater than hyperconjugation. Okay, resonance is always greater than hyperconjugation. So the order of, if I want to talk about the order now, then I will say that the least effect is shown by inductive effect. Inductive effect is not going to show much change, followed by hyperconjugation, and then followed by resonance. Okay, followed by resonance. So please write this down. Inductive effect is least considerable effect. Then you will have hyperconjugation. After that, you will have resonance. Resonance means with mesomeric effect only. Okay, with mesomeric effect. Done? Okay. Now let us see if we can do some comparison. So see in the first case, first of all, you have to, there can be only three things. Either inductive, either there will be nothing, or you will have inductive effect, or you will have hyperconjugation, or you will have mesomeric effect. Okay. So first of all, you look and first of all, you identify if there is any mesomeric effect happening anywhere, plus M or minus M. First of all, look for mesomeric effect. Can you see any mesomeric effect? Tell me, any plus M minus M group?
Yes, sir. Plus M is there.
प्लस एम कौन सा है?
Sir, C.
सी में प्लस एम है, कौन सा है प्लस एम ग्रुप उसमें बताइए.
No, sir. No, sir.
है ना. फर्स्ट ऑफ ऑल मेसोमेरिक इफेक्ट रेजोनेंस के लिए तो पाई बॉन्ड चाहिए, है ना.
Yes, sir.
बट वी डोंट हैव एनी पाई बॉन्ड हियर. सो नो मेसोमेरिक इफेक्ट. व्हाट अबाउट हाइपर कॉन्जुगेशन?
D.
नहीं, हाइपर कॉन्जुगेशन. इज देयर एनी हाइपर कॉन्जुगेशन एनीवेयर?
Yes, sir. And D it is there.
D there. Okay. What is the condition for hyper conjugation? You tell me the conditions.
There should be sp2.
So tell me, for A, is there any sp2 carbon? Is there any sp2 carbon in CS3 positive? अरे आप ये भूल गए, हाइब्रिडाइजेशन भूल गए आप समायरा?
Yes, I thought.
नहीं, so you have your notebook ना, flip pages. Flip some pages. Yes, did you get it?
Yes, sir.
Tell me. For hybridization, what do we need? Steric number, no? Remember steric number?
Yes, sir.
Steric number means, now you tell me, how many atoms are there which are connected to carbon in CS3?
3.
3. So what will be the hybridization? Steric number is 3. What will be the hybridization if steric number is 3? You look in your notebook, there will be the one table made. Steric number and hybridization. Yes, Samira. Yes, what happened? Yes, sir. Oh, you are not getting that table, Samira. See, can you see the now? Steric number 3. Hybridization will be
sp2.
sp2. Okay. Okay, please remember this at least. If not, please yaad karke rakhiye. Steric number and hybridization. Steric number is 2. Hybridization will be sp. Steric number is 3. sp2. 4. sp3. Okay, this will be very useful in organic chemistry. Okay.
Yes, sir.
At least sp, sp2, and sp3. So you can see that this is also what? This is also sp2. And all of these carbons are sp2 carbon because they have 3 bonds. Okay, all of these carbon are sp2. Now, another thing that you have to remember while you are comparing the stabilities, now that you don't have to compare what is common. So you can see that C positive is common in each case, but you have 3 different groups attached to it. In this, hydrogen is only attached. In this, we have CH3. In this, we have 2 CH3 groups, and in this, we have 3 CH3 groups. So in this, we can say that there is no effect, right? There is no effect. There's neither inductive effect nor any mesomeric effect nor any resonance or hyperconjugation. But in this case, can you see that this is connected to CH3? CH3 is a plus I group, correct?
Yes, sir.
Okay. Also, we can see that this is sp2. This is alpha carbon, and there are how many alpha hydrogens? 3 alpha hydrogens, right?
Yes, sir.
So hyperconjugation will be there. So again, here also plus I will be there, and how many alpha hydrogens here?
6.
And here, how many alpha hydrogen?
9.
9. Okay. So obviously, A will be least stable, followed by B, followed by C, and then D will be most stable. Yes or no?
Yes, sir.
Okay. Now, let me write some questions.
Sir, can you scroll?
Sure.
Done, sir. So in this case, I can say that there is resonance. Yes or no? A case, A double bond B, single bond C. Yes, sir.
In this case, what do we have? Hyperconjugation. Number of alpha hydrogen is equal to how much? 2, right? This is the alpha carbon. Hannah? Yes
Yes.
or no? And what about here? Here also we have resonance, correct?
Yes, sir.
Now, how we compare two resonance? A is also resonance, B, C is also resonance. So if you have resonance, then you will look at stability directly proportional to the number of resonating structures. So obviously you can see that since here there are 3 pi bonds, what is going to happen? There will be more resonating structures in the C case than in the A case, right? Than in the A case. And that is why what is going to happen? C will be most stable, followed by A, because again, resonance, then hyperconjugation. So first of all, we will compare resonance. In resonance, we saw that C has more number of structures than A. That is why C, and then A, and then you will have B. Okay.
Done, sir.
Write it down. Done. Okay. Another question will be, you have CH2 positive, okay, and then you have CH2 positive. Here you have NO2 group. Here you have CH2 positive. Here you have OH group. CH2 group, CH2 positive, okay, CH2 positive, and let us say you have Cl group. Okay, now you tell me A, B, C, and D. Okay. Now in this case, you will see that this, okay, here you have hydrogen, right? Here you will have hydrogen. So this is the only thing which is different. Yes or no? Anna?
Yes.
Everything else is same. So you will compare these things only. Okay, you will compare these things only. So for A, I can say that there is no effect. Now for NO2, you tell me what is the effect of NO2 plus M or minus M in the benzene ring? Tell me.
Minus
Minus M. What about OH plus M or minus M?
plus M.
What about Cl plus M or minus M?
Minus M.
Cl is plus M, but the dominant thing is minus I here. Okay. So whenever you have halogens, you will not write. Right. If you're talking about if you're talking about the stability, you will not say plus M. But in reaction, you will say that ortho, or it will be ortho para directing, but it is not plus M. The dominant effect is minus I here. Okay. So it is essentially it is pulling up electrons. It is pulling up electrons. Okay. Now it is quite easy for us to write the order, because plus M will stabilize the positive charge. So C will be most, yes or no? C will be most stable.
Yes, sir.
Anna? Now what will be the next stable thing? Again, here nothing is happening. Okay, here nothing is happening. Here it is destabilizing. Here it is stabilizing, and here also it is what? It is destabilizing. So first of all, you will look at the stable, the most stabilized part. Then this is neutral, I can say, right? It is neither stabilizing nor destabilizing. So first of all, you will write C. This will be followed by A, right? Because in A you don't have stability, but you don't also have destability. Yes or no?
Yes, sir.
Next is, now you have to compare minus M and minus I. Which has more effect, minus M or minus I? Which has more effect, minus M or minus I? We have written this one here. Inductive effect has least effect, hyperconjugation, then resonance. Resonance and mesomeric effect, same thing, right?
Yes,
Due
sir.
to resonance only we have mesomeric effect, no? Okay. So mesomeric effect will be more destabilizing than the inductive effect. So you will first of all write the B part, which is less destabilizing, and then you will write B part, which is the most destabilizing. Okay.
Okay, sir.
Write it down. Let me know if you're done. Done.
Yes, sir. Done.
Now let me write one more question.
Okay. Write this question. Let me know if you're done. Done? Do you write the question? Yes. Okay. Now in this case, you tell me what is different. NO2 is different. OH is different here, and here we have CS3, right? So
Yes.
now you tell me what effect NO2 shows. What effect?
Minus M.
Minus M. OH shows
Plus M.
plus M, and CS3 it can give, right? Because you can see this carbon atom, right? It is what? It is having this CS3. I can write plus I at least, yes or no?
Yes, sir.
But you have to remember one thing. You have seen the last class. When you were learning about so now you can see here in both of the things. See, plus M group, it will increase the electron density at ortho and para positions only. Right? Yes
Yes.
or no? Okay. What about minus M? It will decrease the electron density at ortho and para positions only. Yes or no?
Yes, sir.
That means mesomeric effect, it does not have any effect if it is in the meta position, that is here, right? It is in the meta position, both of these things.
Yes, sir.
That is why here it will not have any effect because it is in meta position. So now if mesomeric effect is not there, but NO2 it will have a minus I effect. OH will also have a minus I effect. Okay, and since nitrogen and there are two oxygens here, that is why NO2's minus I effect is already very high. I hope you have written the order of minus I also. You have written that now. So you can say that this will be so stable because we have plus I. This will be less stable. This will be destabilizing. This will be very destabilizing. So the most stable will be C, followed by B, and then followed by A. Okay. Okay, Samira, you got this? Yes or no?
Yes, sir. Gone.
Okay, fine. So this chapter is complete. Okay, this chapter is complete. I was thinking that can I start those SNP block? आपका आ रहा है SNP block? Now tell me.
Yeah, it must be coming in the finals.